Okay, first of all, good morning, good afternoon, good evening. It's a pleasure to have the chance to present this Excel file to you. So in my presentation, I will start with the measurement model. So I will jump to the measurement model used in this spreadsheet, and then I will describe the spreadsheet in more detail. And the spreadsheet was based on a published work on Talanta in 2019. In this case, the uncertainty model is divided into intervals below 2 times limit of quantification and until limit of quantification typically, and above 2 times limit of quantification where the performance is expected to be constant in a relative way, while below 2 times limit of quantification the precision will be constant in an absolute way. So for this first interval, the expanded uncertainty can be calculated as 2 times coverage factor of 2, and this is for approximately 95% confidence level, times a square root where you have different terms. So the first term is for sample heterogeneity. So we take the mean range of duplicate results from the analysis of heterogeneous samples, and these duplicates are performed under repeatedly conditions with data from this first interval. And we divide this mean range by 1.128 to get there the repeatability standard deviation, from measurements of heterogeneous samples. The second term that you see in the slide is the iterate precision standard deviation from the analysis of homogeneous samples, because typically we check the iterate precision by analyzing something homogeneous in different days. And then you have here a term for the repeatability standard deviation from the analysis of homogeneous samples, typically collected during the method validation. So if we take this subtraction here, so we have the between days variance that together with the repeatability from the analysis of heterogeneous samples gets the precision component of our measurement uncertainty. So the component for the so-called systematic effects, for the management of systematic effects, is this last term, where we have here the relative standard uncertainty of the mean recovery. I already presented the equation that can be used here. And then we have here the measured value that can be the original or the corrected value for recovery. So the relative standard uncertainty associated with this mean recovery is estimated by this equation. This is exactly the equation that I presented yesterday in my second presentation, slide 11, where it is divided the standard uncertainty of the mean recovery by the mean recovery itself to get the relative number. So, and for interval 2, so above 2 times limit of quantification and until the maximum concentration of the analytical interval, the equation that is used to calculate the uncertainty is this one. So we have the expanded uncertainty for 95% confidence level again, coverage factor of 2, measured value, corrected or original one, and then you have here the uncertainty components that are combined in a relative way. So the first term is equivalent to the first term of inside the square root in the question that presented previously, but here we have a relative range of duplicates of the analysis of heterogeneous samples obtained under repeatability conditions in interval 2, so above 2 times the limit of quantification. And this is the repeatability standard deviation, or the relative standard deviation of repeatability for the analysis of heterogeneous samples. We also have a term for the relative standard deviation of the intermediate precision, for the relative standard deviation of repeatability, so terms are squared there. And then you have here the term for the relative standard uncertainty of the mean recovery. So these are the formulas used in the spreadsheet. The spreadsheet is divided in different sections. So in fact, the spreadsheet that I'm presenting has a different sheet for different parameters. This was used for analysis of different elements in sediments, and then we have a compilation of all data there. So all these folders are similar, but include results from different elements. In the left corner, up corner of the spreadsheet, you have some instruction about the structure of the spreadsheet. So it is divided in 3 sessions for precision, 1 session for analyzed recovery, trueness, uncertainty list there, and it is assumed that there is no additional uncertainty components to be considered. But you can always add yourself, because the spreadsheet is protected with a password, but the password is top 400, and it is in the cell A1, so it is not, I would say, its password is known. And in the right corner of the spreadsheet, you have the estimated uncertainty for interval 1 and for interval 2, below and above 2 times the limit of quantification. Okay, so in the first corner of the spreadsheet, after structure being presented, you have this corner where you should put the parameter, the matrix, the units, and very important, you have to put here the limit of quantification, in this case 5 milligrams per kilogram. Depending on this limit of quantification, the software manages the pooling of information for interval 1 below 2 times limit of quantification or above 2 times the limit of quantification. Section A, second section in the right corner, in the right direction of this spreadsheet. In this section, you should enter here duplicates from the analysis of heterogeneous samples in interval 1 and 2. So you just need to put here duplicates from the analysis of heterogeneous samples. So same day, you can see here that the replicates are obtained in the same day in different columns. And then the software defines for you if you are in interval 1 or 2. If you are in interval 1, it calculates a mean absolute range. If you are in interval 2, it gets the relative range to get the mean relative range for interval 2. In this cell, and all cells that you can change are in this pink color. In this cell, you can decide if it is important to take the heterogeneity of the sample into account or not. So if you put irrelevant, it means that you don't have this issue of heterogeneity, and you skip this part of the cell. So you skip the first term of the uncertainty models that I just presented to you. Then you have here a part where you put information on the repeatability of the analysis of homogeneous samples. So you have here 3 columns where you put results from the analysis of homogeneous samples analyzed in the same day and with the concentration of interval 1. You have also for interval 2. So the software pulls the standard deviations for you and estimates the precision and the repeatability condition for interval 1 and interval 2. If for some reason you don't have this information, because you decide not to estimate the repeatability for homogeneous samples because you are not so interested on that, you assume it is irrelevant and you somehow skip that term, that subtracting term in the equation, and you over-evaluate a little bit uncertainty, but you can do that in order to avoid the need to collect that information. So the software is rather flexible regarding what you have or not. If you over-evaluate the uncertainty, shouldn't be a problem. And then we have here a section C, where you put the results of the intermediate precision from the analysis of homogeneous samples. You should put results from the analysis of samples in interval 1. So typically, if you have samples, homogeneous samples being analyzed in different days for your quality control, and if they are in interval 1, you put that information there. You can have 3 samples and you pull the standard deviation from these 3 samples, and you have data from 3 samples also from interval 2, and that information it is pulled. If for some reason your intermediate precision is controlled only above 2 times limit of quantification, this shouldn't be a problem, because this relative standard deviation is used to over-evaluate the precision below 2 times limit of quantification by taking this relative value and somehow converting in what would be expected at 2 times the limit of quantification. And then we have this part of the spreadsheet. You have a summary of the uncertainty from precision, where all precision components are considered, heterogeneity and with precision there. This part is for heterogeneous samples, and this other part is for homogeneous samples. And we need to evaluate the uncertainty and precision from the analysis of homogeneous samples. For instance, in our quality control, you can decide to analyze samples, another certified reference materials, and they are more homogeneous than real samples, so you will evaluate the uncertainty skipping the heterogeneity component. And then we have a part for the mean recovery and the standard uncertainty of the mean recovery. This corner, you can put results from different reference materials. In the spreadsheet, the header of the table suggests that you should put the results from proficiency test samples, where you have here the reference value and the uncertainty of the reference value, and then your measured values in 1 day or several days. So we can use this if you have proficiency tests, but you can also use if you have proficiency test samples, spiked samples, certified reference materials. So anything except spiked sample with native analyte you can put there and take into account in our recovery calculations. And the same formula or the same algorithm is used if you have one certified reference material being analyzed in different days, or if you have several certified reference materials. So the formula is interchangeable, I would say. And in this part, it is assessed if mean recovery should be or not should be corrected on results. And then we have a section where all recovery estimated from the analysis of different reference materials are compared with each other to see if the estimated recoveries are compatible. If they are compatible, like I described in my second presentation, if they are compatible, it means that there is no need to add additional uncertainty component for the variation of recovery with the sample matrix. If we have some differences, like in these red cells, where the recovery estimated for round 12 and 13 are different from round 1. If we have things like that, and if we are not able to distinguish to divide the scope in different types of matrices, you should add this additional component for the between sample variability of recovery. And then we have a section that summarizes all the information. It tells if you need to correct the results for recovery. It gives you the uncertainty for interval 1 and for interval 2, standard way. For interval 2, it is a relative number. For interval 1, we have over-evaluation of this component by multiplying by 2 times the limit of quantification. And here you have the uncertainty for heterogeneous samples and for homogeneous samples, and then we have a balance of the relevance of uncertainty components. So we have precision and trueness together will be 100%, and we also, from both these two parts, we can also distinguish the component for matrix effects and from sample heterogeneity to understand how relevant these contributions are. So let me finish answering to the question that for sure you will have for me. So first of all, the Excel file that I will make it available to you. That this Excel file should be checked by you. So you should check the algorithms. They are not so complex before using it, because so the end user of the spreadsheet must understand and agree with the formulas used. So this is a requirement. If you are an accredited lab, you have to check all your spreadsheets to be sure that you agree, to be sure that formulas are fine, and that you understand what is being done, and that you understand both the scope and limitations of these algorithms. I will make this link available in the chat. It will not be there forever. I will monitor the number of downloads, and then I will remove it from this link. So thank you very much for your time and for your attention.